Hello everyone. Today I'm going to demonstrate my Capstone project, which is about a token monitoring dashboard for federal agencies. It uses multiple multi-agent AI decision to support the monitoring of token usage, along with the intake pipeline for contracts, renewable timing, and accountability. So before we proceed, let me go ahead and start the system itself. Let's see. All right, so we'll start the system. What we're going to do today is once the system starts, we will validate it. So the next, the system has a RAG system. We'll cover that. So we'll validate the RAG system. After that, we will query the system with some guardrails to demonstrate the guardrail ability to generate the desired output. We'll also take a look at the normal operation of the system, and then we'll simulate a tool failure, and we'll take a look at that operation again. At that, once a tool failure is activate, what's the outcome of it? How the system responds to it? How the system call for human in the loop action and other type of actions such as logging and stuff like that. So while it's running, let's go back to what's the problem I'm trying to solve. So what we have at the federal agency today is we have a contract that are used to purchase those tokens, and they are stated in dollar amount. And at the same time, those tokens are used by the whether it's in AWS Bedrock or Google Cloud provider, Vertex AI, and they consume. And so there is no correlation between how much the contract value, how much contract is left, and how much is the tokens has been used. So there is no single viewpoint to see that. You can reconcile that through like manual reconciliation. You can look at the cloud billing, the ServiceNow, the email thread, but that's tedious, and so that's what the system is supposed to solve. In addition to that, there is a policy within the agency that says if your token consumption usage exceeds 75%, you need to have a contract in place already to kind of replace that, be a backup, or like replenish your token use. So today there's two questions that the users are asking. How much of each bureau's token contract has been consumed, which we need to know, and it's very renewable on track before the contracts run out. If we cannot answer those two questions, we run the risk of mission critical AI workloads, which can be disrupted. So you don't have money in your account to use token, or you're overusing token, then you're left with a bill to pay. So that's a problem today. So the goal here is we have basically two agents in place. The user monitor. So that's it's looking at in real time how much AWS is consuming, how much GCP is consuming, and it has a tool that goes and fetch those token usage. The other thing so now we know that how much is being consumed. We need to know also how much is in the pipe as contract, like what's coming, because this will replenish what's already been used today. So that's the RAG. I'm using a RAG system for that. And then these combination goes into an agent that does a gap analysis between those two and produces the dashboard. So this is the schema for the RAG. Let's see if the software is ready to be tested. We'll come back to that. So we're gonna validate the RAG system in a bit. So it looks here. We go back here, it looks like it's generated synthetic data. It has used some of the existing qualifying data into the system. It has done some chunking. It has loaded the corpus of data, and the embedding has happened. And so let's do a demo now to see to validate the RAG system itself. So the demo I'm running here, let's see. So it's gonna take a while, maybe not, hopefully. There we go. So this demo here, the demo one, for example, it's a general semantic query that searches approved status for bureau token requests across the whole store with default value k is equal to 5. It shows a baseline semantic retrieval with no filters. So that's what it's showing right now. The second demo is like searches for vendor pricing code, and we can see it here. The second demo is a vendor pricing code. We have this with a value of k is equal to 3. So there's only 3 in that. The third demo is it's excluding what we call searches pricing code for a specific request ID. In that case is 1001. And the all superseded pricing version is filtered out automatically. So here we see it's excluded. Here we see it's included in that other demo. And this is where it says it's the superseded value or input is still here. So we know it's working that way. What else do we have? Demo 5 is in the direct active version lookup. So it fetches the active pricing section for R101. And by the exact metadata matches, bypassing semantic search entirely, you use when you need a specific document, not a rank guess. All right, so like that, demo 5 also is searches for token allocation issue filtered to bureaus, like just for filtered by bureau. For example, this one is just for the IRS, and you will see here it's just listed for the IRS bureaus. So that's kind of validate the RAG system itself. The other thing that I would like to show is if here we're doing a query here, and I'm using the filter, the high filter doc type sign CBD, so that to narrow down my output in a way that I get the desired, because I'm using the LLM I'm using is a very small one, so I want it to be as precise as possible, and that's why I'm using a filter to complement the query. So if we do that, all right, here we go. So I'm querying basically show me all active sign CBD. Basically, these are all the contracts. Show me all the contracts that are in the RAG system. And it's showing you here sign CBD, for example, sign is active until 9/30/2006 until the purchase token is all used up. So it's showing you all the active contract today. Now let's take a look at how a normal operation will work. So demo build will get to run. There we go. We run it. All right. So the run here, it's doing run complete. Okay. It's trying to now. Okay. So this is basically this is the dashboard that we're trying to see to show. First thing that we show here is it says incomplete. We'll figure out how. But right here is the usage monitor. So it's telling us these are the bureaus, these are the contract tied to each bureau, these are the contract value, this how much we've spent already on those contract value. And remember the threshold, I mentioned earlier on about the 75% threshold. If that happens, there needs to be some action. So over here, it's saying it's consuming only 55%. So has the threshold been reached? No. So the quality is a success. Over here, it's saying the consume is 40,000 over 50. So 80% consumed. The threshold is 75, so threshold has been reached. Again, there's value, all the values are here, so this quality of success. And over here, so the same thing with BEP. Again, it's saying it's 75, 77, just over the 75% threshold. Threshold is reached, yes. Same thing with OCC. Now we see with US Meat, it pulled the log, the tool has gone and pulled out the data, but it doesn't have a contract value in the system, which is missing. And so it's marking it as incomplete. So it's reflecting that in the dashboard. The next thing is it looks now, so that's the dashboard. The top usage monitor is powered, if you want, by tools that goes out to the provider and gets this token usage real time. The next thing now is the intake pipeline. It looks at contract. That's the way this works is like it looks at email, it looks at the corpora of email, of documents that goes into the RAG system, and it extracts this information. For example, it looks at the intake process and it's able to tell at what stage or each of the individual contract. If we take an example here, it says the IRS. It's a new request from the IRS. It's in estimation phase, and it's a renewal for the contract 01234, which is 01234 here. So it knows, okay, so this is the IRS is, there's no need for a renewal because the consumption is still at 55%, but it's saying, there's already a contract in place. For BEP, it's showing that there is a contract in place for renew that renews the contract 7765, which is this one, right? So there's already a contract in the pipeline that's going to come and replace this one. And so that's good. And it says it's the contract is in the executive approval. So it's almost going to be released soon. We have a similar situation here for BFS. There's a contract for BFS. This is customer estimate approval. There is also new contracts that are in the pipeline that has nothing to do. These are new requests and they are not tied to any of what's already showing in the dashboard. And so interestingly, we have OCC here. There is a contract for OCC and they are already over the threshold. Yes. But we see for OCC, the system says there is no contract in the pipeline that's going to replace that. So that's already tell us there might be a potential issue. So with that, what does a gap analysis does? So this one, I've used Claude to do a gap analysis. So Claude will look at the output of the agent, the aggregator agent that goes to Claude, and it gives concrete action to what needs to be done. So somebody that looks at the dashboard can easily say, oh, for example, let's read about this one, which says action required for BFS 04321. Consumption is 80%. Renewal is the contract renewal is 05 this contract, and it's the customer estimate approval. It says BFS consumed 80% of its 50,000 contract, leaving only 10,000 remaining. Renewal request is at customer estimate approval. Still multiple stages way away from execution, funding prep, funding received, contracting. So these are all the stages that needs to happen, and unlikely to clear before the contract is exhausted at the current burn rate. It suggests to escalate immediately to accelerate funding and contracting step or arrange interim bridge capacity. For OCC now, if you remember, for OCC, it says the same. It's like OCC has consumed 78% of the contract, with 11,000 remaining, and no renewal request was found in intake. Without effective active renewal in progress, there's a significant risk of contract exhaustion before new capacity authorized. Initiate renewal request immediately and escalate to leadership to expedite intake process. That, I think, to me, is like maybe they don't need a renewal. So the other thing also would be to tell OCC, okay, you know what, just be careful what you're using because you're about to run out of tokens. So like that, we have a gap analysis that tells us what's happening between what's in the token usage and what's in the pipeline as far as intake. So the other thing, like US Mint, for example, it was flagged here as incomplete because It didn't have a contract in the RAG system. So let's see. It says here, US Mint has recorded 28,000 in spend. So we're seeing it in the logs, but no active signed CBD. So we didn't see a document to support that was found in the RAG, making contract value and consumption percentages unavailable. Threshold analysis cannot be performed, and no renewal pipelines entry exists. Human review is required. So it's telling, this is where human in the loop. Human review is required immediately to locate or establish the governing contract and assess whether it is at risk or exceeding authorized limits. Okay, so let me just so this is, coupled with that, there's also the logging that goes in place to log all the issues that's happening. I'm gonna go quickly to simulate now a tool failure, which is the GCP. So I may not have mentioned that there are two tools that goes out to get the token usage. One goes to the AWS and query the AWS Bedrock. The other one goes to GCP and queries that. So what I'm trying to do now is simulate the GCP failure. So the tool, this can, if there is no, so we are monitoring that. If that's not monitored by the system, there could be a silent failure. So it would go unnoticed. But we build guardrail in the system so that it doesn't go unnoticed. That's gonna take a bit to start, but let's just see. In the meantime, maybe I can go back to my presentation. So what we've covered so far, we've covered the RAG system. We've talked about so here I mentioned about the query tool. So this is what we're simulating right now. This is gonna fail, and if that's fail, what's gonna happen, right? So the provider is this is gonna fail. It's not gonna have this one, but it's gonna have Bedrock. So some of the values, some of the tokens gonna be missing in the reporting, and the good thing is that this is going to report it to the aggregator. The aggregator is going to report that to the gap analysis. So we'll see what happened in the dashboard itself. Let's see if that's ready. All right. So now we run and see. All right. So it's running. There's a dashboard error. We can see no active contract found for US. Okay, so we covered that before. Here, GCP cloud logging tool fail. Vertex AI spend is absent. Okay, so we know something is happening. All right, so this is the dashboard again. It says here data source failure detected. GCP cloud logging Vertex AI is unavailable. So it's already reporting that along with logs file log from in the back. Over here, you will see, I don't know, let's see, consume 47. So these are low compared to, we go back here, these were 80, 77, 78. So yes, so what's happening, we are missing information from the GCP log. So inherently, the system is reporting, but if there was no, again, detection in the middle, this would have gone without notice. But thankfully, we have built guardrail into the system so that it's even though it's reporting, it's telling you the quality is incomplete. There's a quality degradation here, and because of that, everything is going to be messed up. So it's saying here, for example, let's see, there's a data gap for this one, shows a 40% consumption, but data quality is incomplete. GCP cloud login has failed, and Vertex AI spend is entirely absent. So this is what it's able to detect by this failure. Let's wrap up now the presentation. So why use a RAG system versus, for example, ServiceNow? I could use the API directly to ServiceNow, but if I do that, it will just copy what ServiceNow has and says and propagate stale or incorrect um, status. So versus a RAG system is more interactive. It reads the email, it flags mismatch for humans resolution. Um, So the failure I've demonstrated is the reliability within the core of the system itself. For example, the tool, it has a free state reliability model. It can be successful. It compares the current and the complete. It can be partial, which is an incomplete, so one of the tool fail or both of them fail. Either way, there's an admin alert, there's error that's generated, error log that gets generated. This is the decision tree for the gap analysis. So how does the system work to get to the gap analysis? We'll skip this one. This is a bit on the implementation side. Here I talk about the reliability and human oversight. No anomaly is silently dropped, as I've demonstrated. We have human in the loop feedback. And so I'll end with like the current limitation of the system today. I'm using it's a mock API, it's a mock call to AWS and GCP. I'm using log file that I've generated. So the next step will be to authenticate it with real API call to this provider system. I'm using a full vector stored rebuild per build, so it's rebuilding itself. So versus in the real live production, it will be an incremental in the ingestion of document versioning. So here I'm using Claude as Claude Access for gap analysis. I think it cannot defeat the purpose because I want a self-contained airtight system. So the next phase will be to have an internally host LLM with stronger guardrails. So in closing, I would say this: token monitoring dashboard should not only show spend, it should explain risk, expose uncertainty, and trigger human action before mission AI workload are disrupted. So I hope you get a good insight about my project, and I thank you for your attention. Thanks. Bye-bye.